So we want to talk a little bit about the insulation of the home and the thermal envelope of the home. The thermal envelope is going to be the insulation underneath the floor, the insulation up the walls, the insulation in the attic up above. We're going to create an envelope basically around this home that's insulated and sealed against the weather, and that's going to keep the inside inside and the outside outside for the most basics of it. You're probably used to seeing bat insulation, not bad insulation on the outside wall. That's fiberglass bats. They come in a big long sheet. They're installed in the wall, and wherever there's an electrical outlet or a pipe or another obstruction in the wall like that, that insulation has to be cut and then tried to form around that. That's very difficult to install in the field, and it leaves little voids. Also, where it's tucked into the stud bays there, it leaves little voids. Insulation doesn't work unless it's touching a surface on all 6 sides. We want that insulation to touch the bottom plate, the top plate, the outside wall, the inside of the inside wall, and the studs on both sides for it to actually work. So we use a blown-in insulation. That's what you see here. We put the netting up on the wall. We blow the insulation inside of it. It gets behind all the electrical boxes, gets behind all the pipes and around it, and it's so effective that where the same thickness of insulation is rated as an R21 in the bat insulation, this insulation is rated an R23. So once we've established this thermal boundary, we've got some insulation underneath the floor, we've added additional insulation to that and additional insulation in the attic. We want to make sure that the air that we have on the inside is conditioned as effectively as possible. And the way a lot of us used to build homes was to put the furnace out in the garage, and then we'd take and warm up that air out in the garage, and then we'd blow it underneath your crawl space, or we'd blow it through the attic on top, and then we'd bring it back inside your home. As it's going through the crawl space or as it's going through the attic, it's got the possibility of losing heat. If you have a depressurization system, it can pick up air that we don't necessarily want in the home. So the logical step was to move all of that equipment inside the home, and that's what we've done here. The furnace is upstairs. It's a 95% efficient furnace. It doesn't draw any combustion air. It's a sealed unit, so we're going to pipe in the combustion air from the outside, and we're going to pipe the bad stuff right back to the outside. And then we're going to take that conditioned air now, and we're going to pump it within this conditioned space that we've created, and that's what you see here up in the ceiling. We're pumping down into this ductwork. We're running all the ductwork in between the 2 floors in the home. Very, very efficient system. We thoroughly test ductwork connections before we cover everything up, so we know we're going to not have a lot of air leaking out of it. Basically, we're going to create a tight envelope. We're going to control the amount of air that we put into it, and we're going to test to make sure it's going to all the places that we want it to.